So for our first topic we're going to go over is 1-1 variables and expressions. And we have a few vocabulary words that we need to go over from the beginning. Those vocabulary words include variables. Remember, variables are a symbol or letter used to represent an unspecified number or value. An example of a variable here is this x. And then it says a constant's a value that does not change. That is the number by itself. And this here is the number by itself. Something that this doesn't express or state is that what a coefficient is. And a coefficient is the number that is in front of the variable or the number that is with the variable. So this right here is called a variable term because there's a variable with it. And this is called a constant term because it is just a constant itself. There is a numerical expression, and a numerical expression is just something that contains only numbers. An algebraic expression is something that consists of variables, constants, and or operations. The following are all various ways or forms of saying addition, subtraction, multiplication, or division. So these are keywords that we're going to see throughout while we're translating our verbal to algebraic expressions. All right, so example 1 says to write a verbal expression for each algebraic expression. There are various ways that we could write this answer. It just depends on which term we would use, as there are multiple ways to say specific things, like I said on the last slide, in regards to how we would say addition, subtraction, multiplication, or division. For example, pretty much how you say it, you could say 3 times x squared, 3 and the product of x raised to the second power. There are multiple ways that we can actually write this. We're just taking it and we are writing this verbally. We're translating this into a verbal expression. For this, I will go ahead and just write this as 3 times x squared. However, you could write that as the product of 3 and x squared, as I said. I could also write 3 multiplied by x to the second power. All right, for our next example, 5z plus 16. Again, we're going to revert back to the vocabulary. We can go ahead and say the product of 5 and z plus 16. Another way that this could be said is 5 times z increased by 16. These are, remember, vocabulary words that I'm taking from the prior slide. Okay, example. Or you could say the sum of 5 and times z and 16. There's just multiple ways that we can do this. Okay, for the next one, it says 1/2 a plus 6b over 7. So there's multiple ways that we can write this as well. Just depends on the vocabulary that we're using. So again, the 1/2 a, this is actually multiplication. So what I can say is 1/2 times a, and something for the plus, I can say increased by 6 times b divided by 7. Remember, fractions are just division. Fractions are just division. I could also say 1 divided by 2 multiplied by a, adding the quotient of 6 times b divided by 7. There's multiple ways. Remember, always reverting back to our various terms that are represented by addition, subtraction, multiplication, as well as division. All right, so next we're actually going to do the opposite. We're now going to take the algebraic expression. We're going to write that from the verbal expression. So the first example here says a number t more than 6. A number t more than 6. The way that this is written, it can sometimes be very confusing because it's saying a number t more than 6. So t is something more than 6. So this should be written as 6 plus t. However, you could write this as t plus 6, because if you were to plug in any number for t, let's say 2, 6 plus 2 is the same thing as 2 plus 6. Now this works for addition. This would not work for subtraction. You would have to make sure that for the order of subtraction this is correct, because it would make it different, and it could either, depending on the numbers, make something positive versus negative. And of course that keyword that's in there, more than, let me know that that was addition. And then here for this next one, it says 10 less than the product of 7 and f. Less than would be subtraction, and the product would of course be multiplication. And since it's less than the product of 7 and f, what that really means that we would be doing is subtracting 10. And the product of 7 and f is multiplication. Now remember, when we're showing multiplication in math, the way we show that is actually with the constant and the variable touching. We don't use this multiplication symbol. That's not a good way of showing the product. We could either show it like this or with parentheses, but this is the ideal way when you have a number and a variable touching. Remember, this is called the coefficient. A good thing to remember is that when you see where it says less than or more than, what's going to happen is these terms here, like t and 6, they pretty much like they switch spots, just like 10 and the product is 7 and f, they switch spots. A lot of times when we're seeing more than or less than, we're thinking of those inequality symbols, but for these types of things, these are called expressions, not inequalities. So when we're thinking about less than or more than, we're thinking about addition and subtraction. All right, for the next one, it says 2/3 of the volume V, and that word of, that actually represents multiplication, and it says 2/3 of the volume V. So what that would represent, as it says, is multiplication. So 2/3 times V, or just 2/3 V. All right, now for example 3, it says evaluate each expression for x equaling 6, y equaling 9, and z equaling 2. And so what that means is that whenever we have an x, a y, or a z within an expression, what we need to do is we need to replace the variable with whatever number that is. So we'll replace it and we'll plug that in. So for example, wherever we have an x, we would plug in 6. Wherever we have a y, we would plug in 9. And wherever we have a z, we would plug in 2. So I'm going to replace x with 6 plus y, which is 9. And notice this does not start with an equal sign, and I'm not going to end with an equal sign because this is just an expression. 6 plus 9 is 15. Okay, and next we have x over z. X is 6, z is 2. 6 over 2, or 6 divided by 2, is just 3. All right, next we have example 4. Mr. Martinez orders 250 keychains printed with his team's logo and 500 pencils printed with their website address. Write an algebraic expression that represents the cost of the order. So it's an expression, so once again, we will not be dealing with an equal sign. The first thing we need to do is define our variables. That's step 1. And step 2 is to gather the information, followed by writing the algebraic expression, including that final answer. So for example, we could say, because we're dealing with keychains, maybe we can define that with keychains can be K, and we can say that pencils can be represented by P. So gathering my information, I can see that there were 250 K keychains, and there were 500 pencils, so that would be 500 P. All right, so now we need to write an algebraic expression. So it says for the total cost of the order, so that means that we would have to add those two things together. We would have 250 K plus 500 P. This is my algebraic expression. Again, no equal sign. All right, moving on. Katie estimates that 1/8 of the people that order beverages also order pastries. Write an algebraic expression to represent this situation. So once again, I need to define those variables. My beverages will be B, and my pastries will be P. So looking at what this says, once again, it says 1/8 of the people order beverages. So of, remember, is multiplication. So I have 1/8 B plus the amount of pastries that are ordered as well. This would be addition because it does say and. So Katie estimates that 1/8 of the people that order beverages also, I should say also, not and, order pastries. Try the independent practice on your own, and we will go ahead and check this against the completed practice to see how you did individually.